B.A Geography, Semester 6, Module 3, Functions of GIS. Objectives. Accordingly, GIS has following 4 functional subsystems. Data input from maps, aerial photographs, satellite imageries and from other sources. Data storage and retrieval, and query data management. Data manipulation and analysis, data transformation, analysis and modeling. Data output and display, data reporting such as maps, reports and plans. Theoretical models of GIS, levels, scales of measurement. For any application of GIS, it is important to view these elements as continuing process. Data input. A data input subsystem allows the user to capture, collect, transform spatial and thematic data into digital form. This typically involves a number of procedures. One procedure might be to gather a new data by preparing large scale of maps of natural vegetation from a field observation. The data inputs are usually derived from a combination of hard copy maps, aerial photographs, remotely sensed images, reports and survey documents. There are 4 types of data entry system commonly used in a GIS. Keyboard entry, manually entering the data at computer terminal. Coordinate geometry, entering coordinates of surveyed data using a keyboard. Manual digitizing, widely used method for entering spatial data from maps. Scanning input of existing digital files, that is online retrieval from other database management, is also another way to data entry system. Frequently be capable of greater precision than that achieved during the data collection. The essential pre-processing procedures include format conversion, data reduction and generalization, error detection and editing, merging of points into lines and lines into polygons, edge mapping and tilting, rectification, registration, interpolation, interpretation. Data storage and retrieval. The data storage and retrieval subsystem organize data, spatial and attribute in a form which permits it to be quickly retrieved by the users for analysis and permits rapid and accurate updates to be made to the database. This component usually involves the use of database management system DBMS for maintaining attribute data. Spatial data is usually encoded and maintained in proprietary file format. The functions of database management governs the creation of and access to the database itself. These functions provide consistent methods for data entry, update, deletion and retrieval. Modern database management systems isolate the users from the detail of data storage such as particular data organization on a mass storage medium. A modern database management DBMS is used to create GIS database, that is attribute database. Storage and retrieval mechanisms include the control of physical storage of the data in the memory, disk or tape and mechanisms for its retrieval to serve the needs of the other 3 components. In a disaggregate GIS, this data storage may be physically more from the rest of the system and may meet the database requirement. This module includes the software structures used to organize spatial data into models of geographic reality. Data manipulation and analysis. The data manipulation and analysis subsystem allow the user to define and execute spatial and attribute procedures to generate derived information. This subsystem is commonly thought of as the heart of the GIS and usually distinguishes it from other database information system and computer aided drafting CAD systems. Then development of new derived data layers which may form the input to further analysis is an important function of any GIS. The list of data manipulation and analysis operation are reclassification and aggregation, geometric operation as rotation, translation and scaling, rectification and registration, control determination, data structure conversion, spatial organization of connectivity and neighborhood operations, measurement of distance and directions, statistic analysis as descriptive statistic, regression, correlation and cross tabulation, modeling. This operation or subsystem represents the whole spectrum of techniques available for the transformation of the digital model by mathematical means. A library of data processing algorithm is available for the transformation of spatial data and incorporated in new visual maps. Using these techniques, it is possible to deliberately change the characteristics of the data representation in order to meet theoretical requirements. It is equally possible to mishandle or unintentionally distort the digital map at this state. Data output. Output is the procedure by which information from the GIS is presented in a form suitable to the user. The data output subsystem allows the user to generate graphic displays, normally maps and tabular report presenting derived information. Data output can be in three forms: hard copy, soft copy and electronic form, binary form. Hard copy outputs are permanent means of display. The information is printed on paper, mylar, photographic film or the other similar material. Soft copy output is in a format which can be viewed on a computer monitor. Output in an electronic format consists of computer compatible files in binary forms, etc. Soft copy outputs are used to allow operator interaction and to preview the data before the final output. A soft copy output can be changed interactively, but the view is restricted by the size of the monitor. A hard copy output takes a longer time to produce and requires more expensive equipment such as color plotters, but it is a permanent record. The computer along with GIS software is the heart of GIS. Typically, GIS works on two platforms such as Windows 98, 2000, NT, XP and Unix operating system. Data storage devices such as computer hard drives, optical disk and external memory cards. Data collection devices can be divided into components such as field surveying and point capturing using global positioning system, remote sensing, digitization of existing maps and plans and digital data transfer via internet. GIS software is designed to download, edit, sort and analyze the data. For example, database software, relations database software, geometric and drawing software, soft copy photogrammetry and satellite imagery analysis software. GIS software is designed to process and output the data in the form of graphics, maps and plans. Hardware components include surveying equipments, GPS total station, remote sensing equipment, digitizers, scanners, interactive graphic terminals, plotters and printers. Theoretical models of GIS. Reference should now be made to the existing models of GIS operation, which are broadly similar in nature. These may be considered in two main groups, namely the functional elements of GIS and fundamental operations of GIS. It will be seen that these approaches generally make little or no reference to the very important process as which have been outlined above. It is due to their failure to address these issues that they are unable to offer much help to those who would seek to apply GIS in new situations. In particular, certain socio-economic phenomena need special treatment. Conceptual models tend only to address aspects of the operation or composition of GIS system. They make no statement about the nature of the data representation. The components in these models are basically analogues to the main software components in any general purpose system. They are the problem processor model, the database model, the interference model. However, this is still an explicitly software orientation approach to understand GIS. Functional elements of GIS. Bracken and Webster 1987 outlined 4 functional elements to address the GIS technology. They are database approach, the process oriented approach, an application oriented approach, and toolbox approach. Database approach stresses the ability of the underlying data structures to contain complex geographical data. The process oriented approach focuses on the sequence of the system elements used by an analyst running an application. An application oriented approach defines GIS based on the kinds of information manipulated by the system and the utility of the derived information produced by the system, while the toolbox approach emphasizes as the software components and algorithms that should be contained in a GIS. Fundamental operations of GIS. This approach considers the functions which GIS is able to perform. The operation discussed in this section fall entirely within manipulation and analysis subsystem referred to, and thus are wholly internal to the GIS. The fundamental classes of operations performed by a GIS have been characterized as map algebra. The classes of analytical operations are divided into reclassification outlay, distance connectivity measurement, and neighborhood characterization of the data. These operations can be identified as follows. Reclassification operation transform the attribute information associated with a single map coverage. Overlay operation involves the combination of 2 or more maps according to Boolean conditions and may result in the delineation of new boundaries. Distance and connectivity measurements include both simple measure of interpoint distance and more complex operations such as the construction of zones of increasing transport cost away from specified location, and neighborhood characterizations involve the value to the location both summary and mean measures of a variable and include smoothing and enhancement filters. Sequence of such manipulation operations have become known as cartographic modeling. Levels, scales of measurement. All these features or entities contain information not only about how they occupy space, but also about what they are and how important they are. The additional non-spatial information that helps us to describe the objects we observe in space comprises the feature attributes. The character of an attribute data themselves can influence the utility of the dataset GIS analysis. Which is considerable important is a scale of measurements used to record and report the data. There is already well established measurement framework for nearly all forms of data, including geographical data. These are called levels of geographical data measurements. They illustrate levels of measurement in terms commonly used geographic features. 4 commonly referred levels of measurement are nominal scale, ordinate scale, internal scale, ratio scale. Nominal scales are those variables which are described by name with no specific order. For example, land use, park, residential areas, and so on. These are named data. The system allows us to make statements about what to call the objects, but it does not allow the direct comparison between one named object and the other ordinal variables are those variables which are listed in discrete classes, but with an inherent order. For example, classes of streams like first order, second order. Interval scale, the measurement, the number are assigned to items measured. Data measured can be compared as in the scale. Data measured can be compared as in the case of ordinal scale of measurement. And example, have a natural sequence of temperature measured in degrees. The ratio variable have the same characteristics as interval variable, but they have natural 0 or a starting point. Rainfall per month is an example of ratio variable. GIS workflow. The 5 essential elements that define a GIS are data acquisition, data pre-processing, data management, data manipulation and analysis, and product generation output. The above elements are in a continuous flow process in a GIS. Data acquisition is the process of identifying and collecting the data required for a given application. It includes locating and acquiring existing data such as aerial maps, ground maps, images from photogrammetry and images gathered using remote sensing. Data pre-processing operations, which are concerned with storage and retrieval of data, are associated with receiving data into the system by manual digitizing, scanning, keyboard entry of attributes and online retrieval from other database. Database management governs the creation of an access to the database itself. It provides an easy and consistent method for data entry, updating data, deletion of data and retrieval of data. A modern database management system is usually used for the creation of a GIS database. Storage and retrieval mechanisms include the control of physical storage of the data in the memory and its retrieval for the needs of the other components. The data manipulation and analysis include classification and aggregation, geometric operations such as rotation, translation, scaling, rectification and registration, control determination, data structure conversion, spatial operations of connectivity and neighborhood operation, measurement of distance and direction, statistical analysis as descriptive statistics, regression, correlation and cross-tabulation, and modeling. These elements represent the whole spectrum of techniques available for the transformation of the digital model by mathematical means. The product generation is a phase where final output from the GIS are created. These output products include statistical reports, maps and graphs of various kinds. Summary. By the use of the data sources, data management, data retrieval and analysis, large data is available for the GIS application, which in turn is helpful in decision making, where it helps in understanding the real world better. There are 3 levels in which a geographic information system can be used. They are data management, analysis and prediction. Data management. This is the lower level of application which is used to input and store data, retrieve the data through spatial and conditional queries and to display the result. For the data management type of application, the GIS is merely used as an inventory system with the purpose of storing and displaying information about spatial features. These features include width, the number of lanes, the traffic count for a particular highway. Analysis. The second level of GIS application is the analysis. Here, the user uses the spatial analysis capability of the system. For example, determining the shortest path between 2 locations, grouping the area of land into a larger ones depending upon the concerned criteria and so on. Prediction. The highest application level of GIS falls into the prediction category. What if? It is here that the data management and analysis capabilities of a GIS are combined into modeling operation. Examples: modeling operation for the prediction of the effect of traffic on a particular area at a particular time, predicting the effect of flooding and predicting a particular effect of an earthquake.